So the next couple of videos, we're going to be talking about what are called comparison tests. There are two of them that we're going to be discussing. The first is the direct comparison test, which is, again, a test for absolute convergence. So I need non-negative terms, which we kind of get around by making sure that we're dealing with absolute values. So I have a series. That series will converge if there's some second series that converges, where the individual terms being added are always bigger than the one I'm looking at. And the idea of that would be, if I thought graphically, if I said, I have some partial series, or I have some series where the terms are C of n, and my partial sums are converging here. So this would be my C of n, partial sums. While if A of n is always smaller terms, those partial sums would also have to always lie below C of n. So if C of n is the partial sums converge to something, the partial sums of A of n have to converge as well, because they can't jump past C of n. Again, that's a sketch of the partial sums, not the terms themselves. Whereas if I had partial sums of subseries D of n, which shot off towards infinity, it diverged. And those partial sums are always smaller than A of n, then A of n is going to have to diverge too. This is a really tough one to kind of conceptualize, and I understand that. It is an incredibly powerful test. Very, very powerful. However, it can be tough to pick the right series to compare to. So an example of this. I have the series where n goes from 0 to infinity of 1 over n factorial squared. If I took the limit as n goes to infinity, so the nth term test, that's going to 0, so that's inconclusive. It's not a geometric series because it's not a constant raised to the n. It's not a p series because it's not n raised to a power, it's n factorial, so it's not a p series. And then I could try ratio test, but I want to use this as a direct comparison test. So if I think about 1 over n factorial squared, this would be the same as saying, well, I have 1 over 1 squared plus 1 over 2 squared plus 1 over, well, 3 factorial is 6 squared plus 1 over 4 factorial is 24 squared. What I notice is that if I were to compare this to the series 1 over n squared, my terms are always going to be smaller for the red series. So 1 over n factorial squared is less than 1 over n squared. So and I'm hoping that makes sense. So the series for 1 over n squared is a p series. I have a constant on top, n raised to a power on the bottom, constant power on the bottom. So for the bottom series, p is equal to 2. And since 2 is bigger than 1, this series converges by the p-series test. And then, since that series, the blue series converges and the red series is smaller than it, then then my series, n equals 0 to infinity of 1 over n factorial squared, also converges. And that would be by the direct comparison test. Very, very powerful, but it can be tough to get used to knowing what should I compare to.